on to our overview of number sense development. Number sense is an important topic in kindergarten and first grade math. In our targeted instruction supports, number sense is foundational for both our fluency targeted supports as well as our base 10 supports. In these targeted instruction supports, you will see number sense terms in several of the success criteria. For example, here we have subitizing, rote counting, etc. The purpose of this video is to provide us with a brief overview of these number sense topics to best prepare us to support students in developing number sense. To begin, we will look at some number sense topics that support early counting. The first being rote counting. Rote counting is the ability to say the counting sequence both orally and in numerals in the correct order. 1, 2, 3, 4, 5, and so on. Often students struggle with rote counting when they get to the numbers 11 through 19 because there are some features of our language that can cause confusion in base 10 understanding. For example, the number 16, when written in numeral form, we write 1 followed by 6, but when we're saying the word 16, we begin with the 6. Another feature of early counting is one-to-one correspondence. When a student has one-to-one correspondence, they say one number for each individual object. Lastly, we have cardinality. Cardinality is the idea that if asked how many in a set, a student should say the total amount, for example, 3, as opposed to saying 1, 2, 3, the counting sequence, the rote counting. Cardinality, the final number in that sequence, is your total quantity. Next, students move on to counting efficiently. These are strategies that support students with learning how to count on and count back. First up, we have hierarchical inclusion. Hierarchical inclusion is the idea that if I have a set of objects, in this example, 4, I know that having 4 objects means that I also have a subset of 3 objects, as well as 2, as well as 1. Next, we look for conservation of number. Conservation of number is the idea that these blue counters on the left show the quantity of 5, and these green counters on the right also show the quantity 5, even though the arrangement is different. Some students who are struggling with conservation of number might think that the group of green counters on the right is showing a larger quantity because the counters are taking up more space and they are more spread apart. But a student with conservation of number knows that no matter how these counters are arranged, I'm still seeing the quantity 5 in all of these arrangements. Another feature of counting efficiently is subitizing. When I think of subitizing with our super eyes. So when we subitize, our eyes in about 3 seconds see the group of objects and can see the quantity without having to count the individual objects. For example, these often come up in dot talks, but if I see these counters, I right away see that there are 4 without counting. In a random formation like this, people can normally subitize quantities up to around 5. This is called perceptual subitizing, and fun fact, studies have shown that birds can also perceptually subitize. Sometimes when we subitize, there's structure to support this. For example, if I look at this 10 frame quickly and see that there are 9, I might have seen this as 5 on the top and 4 on the bottom makes 9, or I could see this as a 10 frame with 1 empty, so I know that 10 minus 1 makes 9. We also are subitizing when we roll dice. So if I were to roll 2 dice like this, I would see that there are 3 pips on one and 5 on the other, so 3 plus 5 makes 8. The consistent structure or formation of the pips on the die help me see those quantities quickly. In structured and familiar formations like these, people can normally subitize higher quantities. This is called conceptual subitizing. Conceptual subitizing prepares students for concepts of addition and subtraction. Lastly, we have flexible number sense. When a student has flexible number sense, one thing they can do is decompose numbers. So if we see a quantity of 5, we could decompose that number into 3 plus 2, but also know that 5 could be decomposed as 1 plus 4, and so on. Another feature of flexible number sense is the ability to unitize. Unitizing is when you see objects, such as these 2 counters, and know that they are 2 individual counters, but they can also be a group of 2 objects. This allows us to iterate this group, such as 2, 4, 6, 8, and skip count and see those groups as 4 groups of 2, but also as 8 individual counters. This is obviously supporting us with working with equal groups and later multiplication, repeated addition. Unitizing is also important as students in 1st and 2nd grade develop their base 10 understanding. When we see 110, we want them to see that as 1 individual group, but also know that that is the same as 10 individual ones. Thank you so much for watching.